Question is, the maximum overshoot can be decreased without affecting steady state error given by option A, proportional error controller, option B, gain adjustment, option C, derivative error controller, option D, integral error controller. See, if we go through the concepts of proportional error controller as well as the derivative error controller and integral error controller, we are going to know the derivative error controller is going to reduce the maximum overshoot but without affecting the steady state error. Hence, option C is correct. Question is, statement 1. Parenthesis has higher operator precedence than AND. Statement 2, and has lower operator precedence than OR. If we go through the order of precedence of operators like not, parenthesis and OR are following in this order. See, parenthesis has higher precedence than AND then OR. In this way, the precedences of the operators are considered. Hence, statement 1 is only correct statement. Statement 2 is the wrong one. Hence, only option A is correct.
Question is, we have to calculate the expression for the Y for the logic circuit shown in the figure. The technology used in this logic circuit is TTL gates. Here we need to know one thing, that is, for TTL technology, the floating input acts as a logic 1. That means first gate output here is A, here is AB, here is 1, here is AB. So the output expression equals to AB, which is option D. Is we have to calculate the equivalent inductance or effective inductance between the terminals A and B. That is given as follows. L effective equals to L1 plus L2 plus L3 minus 2M12 plus 2M23. The sign of the mutual inductance is decided by whether the how the current is entering and the leaving. If we consider inductance L1 and L2, in inductance L1 the current is leaving, whereas in inductance L2 current is entering. So the mutual inductance because of these two inductors is going to be a negative. Whereas regarding L2 the current is entering, whereas for L3 the current is entering. So the resulting mutual inductance is going to be a positive sign. That's why plus 2M23 and minus 2M minus 12. If we substitute the corresponding values, 4 plus 8 plus 6 minus 2 into 2 plus 2 into 4, we will get 22 henries, which is option B.
Is how much power is consumed by a capacitance whose value is 0.5 microfarad with a voltage of 50 volts. Option A is 62.5 millivolts, option B 0.5 watts, option C 0 watts, option D 6.25 watts. See, if we consider a capacitance and the voltage applied is 50 volts, which is a DC, means the frequency of the voltage source is 0, means omega equals to 0. The reactance of the capacitor is infinite. Hence, current is 0. So, power is nothing but I into V. I equals to 0, hence the power dissipation across the capacitor is 0. So option C is correct. Question is, two port networks are connected in cascade. The combination is to be represented as a single two-port network. The parameters of the network are obtained by the product of individual. Here, when two networks, that is network 1 and the network 2, if suppose these two are connected in cascade, means the output of the network 1 is given as the input of the network 2. Suppose N1 having a matrix and N2 is represented with a matrix T2, then the whole network is represented with a T. which is nothing but a product of T1 and T2, because individual matrices we are assuming that those are T parameters, then only we can take the product. So option A is correct. Question is, Poynting vector has the unit of, see, option A watts, option B watts per meter, option C watts per meter square, option D Newton. Here we know Poynting vector is nothing but E cross H. Here the units of electric field volts per meter, whereas unit of magnetic field is amps per meter. Hence, the Poynting vector has the unit of watts per meter square. Hence, option C is correct.
Here we have to find out VSWR, which means voltage standing wave ratio. In order to find out the voltage standing wave ratio, we need to know the reflection coefficient. In the above problem, we have incident electric field strength as well as the reflected electric field strength. So the reflection coefficient is given as ER by EI, which is 5 by 10 equals to 0.5. Now we need to know the relationship between the reflection coefficient and the voltage standing wave ratio, which is written as follows. One plus 0.5 divided by 1 minus 0.5, which is written as 3. Answer B. In the given problem, the wave is traveling from medium 1 to medium 2, where the medium 1 is air and medium 2 is a dielectric. Again, the wave is parallelly polarized and it is traveling at a Brewster angle. So in order to calculate the dielectric relative permittivity, we need to know the relationship between the Brewster angle and the permittivities of medium 1 and the medium 2. That is given as follows. Epsilon 2 equals to epsilon 0 epsilon R2. Epsilon 1 equals to epsilon naught epsilon R1, whereas epsilon R1 is equals to 1. So the Brewster angle is equals to under root epsilon R2 by epsilon R1. From this, we can calculate epsilon R2 as tan square Brewster angle, which is given as 13.93 of answer D. Here options are okay. వస్తలేదండి బాస్ ఇది